In previous lesson, we learned that matter exists in three main physical states, namely solids, liquids, and gases. Liquids and gases belong to a broad class of substances that are capable of flowing and are known as fluids. A fluid is any substance which is capable of flowing. In this topic, we shall learn about fluids in motion. Streamline and turbulent flow. Streamline flow. Activity 6.1 to demonstrate streamline and turbulent flow. Click on the word streamline and observe the movement of fluid particles. Observations. At any point, the fluid particles move with the same velocity and follow the same path. The particles do not interfere with each other as they move. Rather, the flow is steady and smooth. Such a flow is called streamline flow. Turbulent flow. Click on the word turbulent and observe the movement of fluid particles as previously done with streamline flow. In particular, note the effect of the barrier. Observation. The fluid particles move in a disorderly manner and the streamlines form loops, especially behind the barrier. This disorderly motion is called turbulent flow. Turbulent flow arises when the particles no longer move in the same linear direction but have different velocities. Conclusion. Streamlined flow is smooth and steady. The paths taken by fluid particles in a streamlined flow are called streamlines. Bodies that move easily through fluids without causing turbulence are said to be streamlined. Turbulent flow is a disorderly and unsteady flow. Equation of continuity. To demonstrate the effect of cross-section of a pipe on the velocity of a fluid, click on the piston P and push it from 100 milliliters to 90 milliliters mark and note your observations. Compare your observation with the following. The volume displaced by piston P is equal to the volume by which piston Q is displaced. This is because a liquid is not compressible. That is, the volume displaced by piston P equals the volume displaced by piston Q in the same time. But volume is equal to cross-sectional area times velocity. Therefore, A1V1 is equal to A2V2. This is the equation of continuity. Bernoulli's effect. Activity 6.3. Experiments to illustrate Bernoulli's effect. Effect of blowing air between inflated balloons. Click on the play button and observe the effect of blowing air between balloons. Effect of blowing air between two parallel sheets of paper. What happens when air is blown between two parallel sheets of paper? Effect of blowing air underneath a paper bridge. Observations. When air is blown between two balloons, they move closer to each other. The same observation is made when air is blown between parallel sheets of paper. Explanation. Blowing air between two objects increases the velocity or speed of air between the objects. This reduces the pressure between the objects, so the pressure difference causes them to move towards each other. Venturi meter. Activity 6.4. Demonstrating Bernoulli's effect using a Venturi meter. Conclusion. Height of liquid column represents pressure. The higher the level of liquid, the greater the pressure. At the narrow section where velocity is higher, pressure is low. Hence, pressure in a fluid decreases as velocity increases and vice versa. This is the Bernoulli's effect. Bernoulli's effect is consistent with the equation of continuity. A1 V1 is equal to A2 V2. Application of Bernoulli's effect. Spray gun. Demonstrating the working of a spray gun. Click on play button. What have you observed? A spray gun is an application of Bernoulli's effect. It works on the same principle but may take slightly different forms, as in the case of spray painting and application of insecticides. Here is an explanation of how it works. When the pistol is pushed inwards, air is forced out through the narrow jet so it escapes at high velocity. This creates a region of low pressure. The greater air pressure in the can forces the liquid up the tube into the low pressure region and emerges as a spray. As the propeller rotates, velocity of the air above the helicopter increases, thereby creating a region of low pressure above it. The higher air pressure below the helicopter then causes a lift force which pushes the helicopter upwards.